Hi, and welcome to the 20 by 24 studio here in Tribeca. My name is John Reuter, and I'm sitting here with Jennifer Trausch, our Director of Photography here in the studio. And we're here to show you today our 20 by 24 camera and the process that we're continuing on. And we've got Scott Shepard here today, and we're going to do his portrait. Okay, and now I'm going to take you through the process of the film that goes into the camera itself, and we're going to culminate with a portrait of Scott Shepard. So come on over and see. All right, well, here's an opportunity for a lot of people to see what a lot of people don't get to see, and that is the film components outside of the Polaroid 20 by 24 camera. The roll I have right here is the negative roll, which is cut off of an original spool that's about 60 inches wide, and here you can see the emulsion itself. What we have here is the silver coated on it, the dyes themselves, and the dye developers, all on this one emulsion layer. And then the component that goes with it would be the positive roll, which is not a light-sensitive roll at all, but has sort of a molecular layer called a mordant layer that actually attracts the dyes out of the negative and lures them over in the diffusion transfer to the positive sheet. The third part of the process is what we call the pod, and what's in the pod is not actually developer, but what we call a reagent. And the reagent activates the dye developers that are in the negative itself, and that begins the diffusion transfer process. And unlike smaller format Polaroids where you have the pod affixed to every exposure, we have a free and open system where we use this chain-driven tray that has each pod set to it. And once we make our exposure and bring the film into place, we do a plunger on the side which actually ejects the pod off the edge of the tray into a nib of the rollers between the positive and negative, and then we're able to start the development process. Okay, here we are at the back of the camera, and as you look inside here, you can see the 22-inch roller that is on the inside of the camera. There's another one on the back that comprises the second set, and what I've got in my hand is the positive roll, and what I'm putting on the end right here is a Teflon brake that keeps the rolls from spinning too freely inside the camera once we're processing, so we get a more moderate turn of the positive film. So I put the film in here, and it actually comes off the roll facing me. And what I do to get it into the rollers is I counter roll it, open my rollers because they're closed right now. Then I'm reaching underneath the camera to grab the positive and just thread it through the machine there. So that's our positive in, and let me grab the negative. The negative also has a Teflon brake on it for the same purpose. So I'm going to put that on the side, load it up here, and drop it on there. So that brake actually sits on a little pin, and you can actually turn pressure on that to keep it from spinning too freely. Once we get it in there, I'm just going to flip this around, reach for the negative here, and there's a small idler roll at the top of the camera. I thread it over that, and then we get it inside the camera, and you see the negative comes inside these two tracks here. This is the only thing that really holds it in place. We don't need a vacuum back or anything like that. The process of diffusion transfer is forgiving enough that we don't need, you can have a little bit of flex in there and not have a problem. So then the last thing to come in will be our tray with the pod on it. Normally we would load multiple pods on here. There are 15 exposures on the positive. We no longer put the full 15 in because this tray chain drive has aged enough so it's kind of slippery. So we now put them every other one. And then the last thing to go in there, very important, this is the genius of the process, is a string with double stick tape, which goes onto the negative here and runs through the rollers. And that's the way that we get the negative up and down in the camera. There's no sprocket holes or any sort of rubber drive to do this. And it was the first reaction that the Polaroid engineers had way back when, and it turned out to be the best, so we've never improved upon the string and double stick tape. Now we're ready to go. All right, let's look at some of the movements and features of the camera. This camera was built in 1978 by Polaroid's engineering and construction groups, sort of a real consortium of different people coming together. Has a lot of interesting attributes for a camera built over 30 years ago. One of the most interesting is the front end. The front standard is carbon fiber, which was actually a very rare commodity in the 70s. And then you couple that with things like a Sears ratchet drive, which allows us to tip the camera down or tip it up. We also have a Sears tape measure in the back that measures our bellows for us. So you have this sort of real mix of high and low tech way back when. The design of the camera is actually quite good for a studio camera. We have about 4 inches of shift in either direction and about 4 inches of swing in both directions too, which is a lot for a camera this size. You'll find that the more you extend the bellows, the more you can use those movements. The lens that we have on here right now is a 600 millimeter Fujinon A. It was one of 5 lenses built by Fuji for the 5 cameras that were made back in 1978. And it's an apochromatic lens, meaning that it's a flat field lens. And it just covers 20 by 24 at infinity. Very little of our work is done at infinity, so it's not such a big deal. We're mainly at about 36 inches of bellows, which is about half life size, all the way out to life size and bigger sometimes. And so the movements and those sort of things are not much of a problem when you're that far out. We have a rise and fall, just about, I guess that's about 8 inches off of center, up and down. And then we also have tilting capabilities. So with all of those in there, we can often take advantage of the fact that the limited depth of field of the camera can be overcome by some of these movements. So if I'm doing a portrait, for instance, and I've got one person slightly in front, slightly in back, and they're about 4 inches apart, we can actually take that into account when we go to work with the camera that way. So you can overcome some of the inherent lack of depth of field that you certainly have with a camera this size. We do have other lenses for it. You can actually use any focal length lens on a 20 by 24. We use a lot of smaller focal length lenses for greater magnification. So at a given bellows, right now we're not very far out, but let's say we were at 40 inches, we would get about 3/4 life size with a 600. But if I were to put a 300 millimeter lens on there, I would be almost getting 2x. So you drop down in focal length at the same given bellows, you have a lot more magnification you can work with. We do have one longer lens in this. It's an 800 millimeter Rodenstock. Which is an old process camera lens that we've mounted onto a shutter, very sharp. And it's actually, a lot of photographers like the extra focal length because it flattens things out a little bit. This is actually slightly wide for the format, so a lot of people prefer that 800. Okay, some of the other features of the camera is the rise and fall. Big camera has a big crank to get it up and down. We do have a lock on there. You can actually see the teeth as it locks into that. We can bring it up and down this way. I showed you before, to tip the camera up or down, we have this super sophisticated ratchet here. This is the fine focus here in the back. Now, very different from, say, a 4x5. When you set this camera up to focus, first you set your magnification. That's the distance from the lens from the back of the film. So once you've set that, you literally will move the camera film plane until you see the subject focused. There's no sort of cranking like that. The fine-tuned cranking is once you get it in there. And we mainly use this just for copy work or still life, very rarely for portraits, just because the range is too broad. So this is the fine focus for that. And then finally, this is the open close on the rollers. This is open, that's closed. And this little projection here is the pod plunger. So once we make an exposure, I will push that in. That'll throw the pod off the end of the tray, and that's where we begin our process. Okay, now we're getting ready to do a portrait of Scott. We've set up a fairly simple lighting situation just to keep it kind of on the simple side. We've got 2 Broncolor graphites running 3200 watt seconds, so we're firing a full 6400 watt seconds for this portrait. That sounds like a lot of light, but it's actually kind of a moderate amount of light for this camera. And for this shot, we've actually racked the camera all the way out, as far as this lens will go. So we're going to do a 1.5 times life-size portrait of Scott. And to help me with this is my colleague, Jennifer Trausch, the director of photography here in our studio. Jennifer is primarily responsible for most of the running of the camera. I just do the showbiz these days, apparently, but Jen's the real heart and soul behind the camera. So now I think it's time for Scott to come in, and we're going to set him up. I've just taken my light reading here, and while normally this film is ISO 100, all this bellows extension forces us to reconfigure the ISO. So our method of doing it, and everyone has a different way, is to reset the ISO based on the bellows loss. So we're now at ISO 16, which suddenly you had a fast film becoming a slow film. That's why we need so much light. So Scott's going to hold very still, and Jennifer now has to move the camera to focus. We're at 1.5 times life size, so our depth of field is probably only going to be a couple of inches. So it's real critical that Scott holds still. He's being very good. He's barely moving a muscle right now.
Can you go up 3?
So, and you can see this camera operation really is a two-person operation. To do this by oneself, as you can see, particularly at a bellows extension like this, is pretty difficult. To have to run back and forth, tweak it up, tweak it down, shift to the right, do a little bit of that stuff. It's much, much easier to do it with two people and much more efficient over the course of a whole shoot.
Down one. And close.
Okay, lens closed.
32 even.
32 even. Okay, now that we've closed the lens, Jen can bring the film down. And this is a new case of film, so we have to pull off a full sheet of it. When they spool it at the factory, that first sheet has sort of got fingerprints and perhaps some light leaks on it. So we're going to take off a whole sheet. And it's important to line up the positive and the negative so that when the film does track through the rollers, that they won't go off in different directions. Okay, last thing Jen's doing is closing the rollers. Okay. And are you ready, sir?
Sure.
Okay, on 3, looking right at the lens for me. Okay, 1, 2, 3. There we go. Okay. So what we need to look for, very important, that our rollers are closed. Otherwise, you got a problem. And now Jen's going to hit this plunger here. As I showed you before, that pod's going to drop off the end of that tray. In between those two steel rollers that we saw before, where the negative and positive are now meeting. And when she's ready, she's going to hit the button, which engages the motor inside the camera, which drives it for about 6 seconds. That's enough material to be about 28 inches, which encompasses the 20 by 24 with the black line at the top and the bottom. And as you saw before, this is all roll material, so the last step she'll do is to bring it down and cut it off. And we'll let it go for the duration. This particular film develops for 150 seconds, a little bit longer than our older Polaroid films. And now she's sending the negative back up to the top for safekeeping, so it doesn't get struck by light.